Good afternoon and welcome back to working with Ruby on the Raspberry Pi. So yesterday we worked on our code a little bit and we started adding commands to be able to change our directories quickly. So how Ruby works, hopefully you're getting the hang of this. Everything is an object. So how do we define an object? We define an object with the class method. But we can also define other variables within our class method with the define method. So we're going to change our code here just a little bit. We're going to do some tweaking to our code and we're going to start adding definitions. So if we take a look at the code that we have already, in our class of my command we have a global variable with a procedure to run a system command. Oops. And then down here we associated our global variable with a global constant. We did the same thing for our directory path and we linked that to a constant. Now we can go through and add a little bit more code for easier using Ruby to create directories and files, but that takes a little time and we can go through it, but it's not really doing all that would kind of defeat the purpose. That would be more of these tutorials. These are for you to help work with your Pi a little easier, not really trying to reinvent the wheel here. We can do it an easier way with Ruby by just using the system commands that we already have. Mind you, you can do it the Ruby way and build an entirely brand new shell overlay for it, but for most people, especially for people that use RetroPie, you don't want to spend a lot of time having to pretty much reinvent the wheel and redo the whole, make a brand new directory tree and program to interact with it. So we're going to touch base on that. We're going to talk about the define method, and we're going to add a little bit more system commands that's already associated with the Linux kernel to work with our system. So we're just going to go ahead and jump right into it. And by the way, if there's anything that I've left out, or if there's something that you're not really sure on, please by all means ask away. There are some really good sources online, especially on stackexchange.com. There's a lot of good sources out there for using Ruby. Now to develop your own Ruby code. Well, before we get into it, I will show you something how Ruby works. So let's go back into middle school and high school and talk about the evil math that we had to learn then. So with Ruby, it works. It is like one of the best calculators out there. To show you what I mean, if we type in 2 plus 2 plus 2, hit enter, we get 4. We go for, just be cheeky, 420 times 5 2100. So it can do basic math. It can do algebraic calculations very easy. It also handles Boolean logic very well. So when we were writing our code, the best way I can describe this is when we're writing our code, if you haven't noticed, it looks kind of like a math problem, where we're kind of reading an instruction manual on how to do something that's written in a mathematical format. So when we go to assign our variables, like if we go x equals 1, we'll go to y equals 10. Oops. Go ahead. Oh, just make a new one. So we go x equals 2, y equals 10, a equals 6. So we have our variables, just like in math, that's equal to a number or associated with a number. So we go a plus y divided by x, we get 11. If we do x plus a, we get 8. So very easy to understand. This is how the Ruby language works. So when we're working with it, yes, we were still working in a mathematical formula, but it's in a way that is like more of reading a book. We can even do things like with if statements. If a is equal to 6, puts a is equal to 6 in their if statement. So there we have it. 6. So we can do stuff in this manner. Now notice here that I put 2 equal signs. So if we use just 1, that means this is equal to this. 1 is equal to a. We'll just use this for an example. So this is 1 equals a, like in math. If we use 2 equal sign, that's telling the Ruby interpreter that 1 is equal to a. And then we have a couple of others, like we have the equals and greater than or less than or equal to. So it's pretty easy to work with. Or we can also use less than or greater. So we put a is greater than or. Let's see. Yeah, we can put a is greater. I'm dyslexic, so if I get these backwards, then forgive me. To x. True is a false. So you can see how this works and how we can use this to our advantage for doing debugging and checking our code. But enough with messing around with math. Let's go ahead and jump into our definitions. So down here, instead of using our constants and linking our variables to it, what we're going to do is we're going to take this out and we're going to start off with def, and then we'll put start x, and then start x, under that we will put brain fart. That's okay. I think I need a little bit more coffee. That's what I knew. That's right. That's right. Okay. So we're going to put, seeing how we already have our class, everything in there. So what we can do is we can put A equals star X, and then underneath it we can put A actually we don't even need to do that, we can do it right here. A equals start X dot call end. So we can't use start X here to test it out, but we can use the update and upgrade. So we'll go ahead and put define update A equals so let's check this out to make sure that our code is working right. So we type in upgrade. No local variable or method of upgrade or update. Oh, I did upgrade. Update. Okay, so not working. So how about we do this? We can take we'll cut this out and put this in our update definition. Oops. There we go. Then we can go update grade equals did I do that right? Yeah. Then we can call our call our process right here, or procedure. So let's test this out. Undefined variable method. Directory equals process. And I do have it outside of a class. Oh. Gotta love that I'm dyslexic and it's hard for me to spot stuff like that. Update. Modify. Now it will work. So we can define our commands or define our variables in a block of code. So with update, what we're doing when we call our update variable or method, now it is going to run the global variable of update that's linked to the procedure of the sudo apt-get update. Same thing with the global variable of upgrade, and then we are calling our procedures into it before it exits out. We can do this now so we don't have to go back and keep adding the .call in order for our procedures to work in our command line. Now let's say we just want to do it like this. Cut this back out. Let's put this back in our class. Let's run it again. So why do we want to have our global variables inside a class and not within our definitions? Well, you can do either way. It doesn't matter. When you put them in a class, though, then you can associate them a little bit easier. You don't have to keep going. With the class structure, it's like a library that you can pull from, or from a like if you go to the library and you're trying to find a book and you go and up to you use the Dewey Decimal System. With your class, everything is organized within that class item. Everything outside of it is a global aspect for the interpreter. So if we go to require this script into another into another project, as we will do here in a minute or a little bit, we don't have to go and find define *x. We can use the global variable for it for the procedure, or we can call it in that manner, just like this. So we don't have to go back and keep having to redo all of our code here. But with *x, we're going to go call our *x procedure end. Now the cool thing about this is we can, if you remember right, we can add an if statement in our *x definition. So we can say is if *x, where if x Windows server is running, do not start *x. It will do not boot into Raspbian. This will add a failsafe to where if you use this, unlike with regular Linux command, if you go in and you type *x over this, or if it finds a X Windows session running, it won't duplicate a new one and cause a conflict with the X authority files. So we can do this to make sure that nothing overlaps and overlays and gets messed up, and it will throw out an error telling you that, hey, look, there's a *x already running. Show you an example. Let's go ahead and do our retropy definition. Retropy. We save this. So we go ahead and try to start retropy up in Kodi. It would give us an error. Following SDL mailing. Okay, yeah, I know it. I'm in this VNC server, so it's not going to pick it up. But if you try out, if you're in Raspbian or have a X Windows session open, and you try to run RetroPie on it, it will throw a failsafe because it recognizes that there is already an X Windows session with a graphic interface already set up, and it will throw out an error saying it cannot start up. We have to close out the X session, go back to the main terminal, and then use the command. If we use start X, it will start another one on the overlay over it. Actually, it will start us into a root Raspberry desktop environment, but it will still conflict with the X authority file. So we can add a if statement here, which we'll go into it a little bit later. Right now we want to keep working with our definitions. So we have our start X, we have our RetroPie. Let's define our Cody. Call and let's see, so we have our update. Now while we're here, we're going to go ahead and add a command for nano. And we're going to do this because it's going to be a lot easier just to go ahead and use a nano call for working with for scripts and doing editing in a interface, rather than just trying to make a new one for Ruby. It's not that hard to do in Ruby, which I'll show you the Ruby way here in a minute. But let's go ahead and add nano equals procedure system nano plus plus RGF dot gets. Now I'll explain this here in a minute. We'll put print file name new file name. Before that, if we remember, if we type in our dir.pwd, it will show us what directory we're in. But we can also use it in this format. So if we do the system nano plus print, we'll go ahead and show you how that works to make sure this code is working right. So we don't have a definition for it, so we're just going to call our global variable. Bash call cannot. Oh, not in it, so we have an error. Okay, syntax unexpected string print Okay, so it doesn't want to take a string. Unexpected identifier. Okay. So we're going to put all of this in quotations, but what we're going to do in this quotation is we're going to add the pound sign followed by our bracket. Now doing this, we can put in code within the quotations. So doing this, system nano get, oh, we need to close it out here. Yes, see if it will accept this syntax. Nope. Let's see, unexpected string. Require syntax error, unexpected identifier. By the way, I don't try to do this pre-handed, before I do these tutorials, because I want to show you the debugging process. I mean, I can go in and make sure that all the code's working right beforehand, but this is how you can get an idea and a concept of what coding really is. There is a lot of debugging, there is a lot of tinkering with the code to make it work the way that you want it to. And it can be a little time consuming. Alright, so we have our global variable equals procedure. We want system nano. How did I do it here? Procedure, print. That's right. So let's just take this out for a minute. We just want to do basic stuff. Save. Test it out. That gets unexpected string end syntax error. I know what I did. Okay, instead of doing it this way, I'm going to take this out. We're going to take this. We're going to go ahead and make this into double quotations. But here, what we're going to do is because we want to get the argument, or we want to get the user input with the nano command, and so it puts it all together. Let's double check. There we go. So let's call our nano. We'll call this test. And as you can see here, we're in the GNU Nano text editor, and our file name is called test. So we are in our home directory. Show hidden. Yeah, we didn't save it, so no, it's from another script testing. But that's how easy it is. So let's explain this a little more. Okay, so in our global variable nano, our procedure is calling the system command of nano, and then inside this we are also telling the Ruby interpreter to get the user input to name the nano. So what this is doing would be the same as in the Linux command line of doing nano test. It is doing the same thing. So that's what ARGS stands for, and the get is telling Ruby to go get what the user is putting in. Fairly simple. So let's go ahead and make a define with definition for nano, and then nano.call. End. Pretty easy, right? Now we can do the same thing with the directories, but we can either do it the Ruby way or we can do it with the Linux way. We can do it with the Linux way the same way as we just did in the nano procedure. The only difference is in here you would put in, let's see, what is it? I'm trying to remember the Linux command for making a directory. Anyways, that's what you would put here in the system. Instead of nano here, you would put in the argument, Linux argument for making a new directory with your argf.gets. Then it will make the directory of where you are in at. So for an example, I will show you how to do this the Ruby way. Let's go over and go call our desktop. Call. And by the way, once we do our definitions for our directories, we don't have to put in the .call anymore for calling our directories. Same as for our update. If you notice, we don't have to have it as a constant or capitalized, and we don't have to use the call method anymore. So with this, we're going to go dir.mkdir, and then we can put in our dir.pwd. We don't have to do this, but it makes it a lot easier. And as you see, we have a brand new folder here, or directory, called test. So let's explain what the code is here. dir is our constant, meaning we're pulling up our directory constant like we are with our desktop constant that we made, and we're telling it to make a new directory in a string, and then we are giving it, passing the arguments. And in the arguments, we're telling it to, in our current directory, dir.pwd stands for in the directory that we are in, add \test, because this would be the same way as doing dir.mkdir. Instead of doing it this way, we would have to go home pi desktop test. Okay, so what we did here is the same as putting in the full directory tree. We can even change this if you don't want to do it in your current directory. Let's say we want to do it in our documents folder, then we can go here. We can go put it in our documents, and then instead of not having to pull up the documents directory, we can make a new directory in our documents folder in any directory that we are in. So this is the Ruby way. Now making files the Ruby way is easy enough to do, but there's some drawbacks to it, especially working in IRB. There's not a lot of output information for the user to work with, and it doesn't give you like a text editor. What it does is it's using code to create your file and then writing to it. So for an example, let's get rid of that. We're going to put my file equals, we're going to call the file constant dot new, and then we're going to name it hello, and we can make it a txt. We can make another RB file, Ruby script. We can make a bash, or we can make a Python. Doesn't matter. Here, this is how we can create files of any variation with Ruby. So we'll just go ahead and make it a text file. Now we can also pass the argument with W plus, which means it will be read and write. And you can also there's a couple of more arguments that you can pass, like you can have it to where you can open up an existing file and it will add to it won't rewrite everything, but it will add to it at the bottom of what's there, so it'll add a new line and you can add to it. If you pick up the Learning Ruby book from O'Reilly that I showed you in the first tutorial, it will have the full list on how to do this. So we have made, as you can see, we have now the hello text file made. It is open. So how can we write to it in Ruby, in the Ruby shell? So we go my file dot, what was it? And there is a lot of stuff here. So having a book here, especially with me, there is a lot to remember when you're doing this. So having a source book to look at is very nice to have. Math. Don't need strings. I need to go this way. Hashes, working with files, directory stream, new file, open. What was it? Oh, I'm so trying to remember how to do this. Yeah, I really don't do this method right and work with files because it's nice to be able to amend stuff on the fly, but for trying to write full-blown scripts or files, it's not very convenient to do. Let's see. So let's go ahead and go to our web browser, and we can look this up real quick. Where is it? Really? Yeah, it's like you just saw how dyslexic I am. Let's see. Where was it? I just doing that. I need. Here's the list of the argument. All that stuff. And how you can do it on one line. We don't want to do that. If I remember right, it was right, and then test 1, 2. But did it right. uninitialized constant my here we go. Yep, now it's written. As you can see, we have 10 characters written, and then we want to close my file. Always remember to close the file when you go to write into it. So now it's closed, and then you can check if it's closed by going my file dot true. So yes, it is closed. And if we go over here and open it up, we will see test 1, 2. So that's an easy way, well, it's a way to be able to make stuff on the fly if you need to make a note of something, or if there's a issue that you needed to fix right then and there. That is an easy way to do it. You can even go as far as calling a certain line, as in as you can see, if we make an error in our Ruby script, it will tell us the line that it is, what line the error is on. So we can tell the Ruby script to open up that file, find that line, print out what's on that line, and then correct the line, and then close the file back out. As you can see, is not the most graceful way of doing it. Which is why I told you to go ahead and make a nano command. But it's nice to know how to do it. So I don't want to keep going, and I'll try to keep these tutorials as short as I can. But there is a lot of information that I'm trying to cover and trying to explain everything to the best of my ability in a short amount of time. But I do suggest going ahead and doing your definitions for your directory commands. So basically do this right here down in here instead of linking it to a constant. So instead of doing this, we want to define home and define this desktop. So I'm going to leave that as an exercise and practice for you to link your directory commands to definitions like we did up here. Make sure you always end your definitions. And I will leave it. Let's see. What do I have here? Okay. Oh, discard selected. I will leave it here for now. Let's see how much time we got going. Reboot. Ooh, 43 minutes. Yeah, I definitely gotta probably gonna have to cut this into 2 parts. But other than that, y'all have a good one.